This call is now being recorded.
Okay, so this is the eight fundamental identities. Last time we talked about the process of simplifying trigonometric expressions and finding the values of other circular functions using the identities. And now we have the proving trigonometric identities. Take note that when proving trigonometric identities, you have to manipulate one side of the equation to make it identical to the other side. But there are cases that you have to manipulate both sides so that so that the left and right side become identical. Okay, I will be adding somebody to be the co-host so that you can admit them. Okay. So may mga co-host, so kindly admit na lang. Okay, this is a little intro lang before we proceed to the main lesson. So this is the main lesson. This one. Okay? Okay, so let us prove these identities. Okay, hopefully visible siya ha. Okay, the first identity is secant x minus sine x times tangent x equals cosine x. Okay. What you're going to do here is to manipulate the left-hand side. We will manipulate the left-hand side of the equation. That is secant x minus sine x times tangent x. What you're going to do here is to transform secant x in terms of cosine by reciprocal identity that is equal to 1 over cosine x minus sine x times, we know that by quotient identity, tangent x equals sine x divided by cos x. And that becomes 1 over cosine x minus sine x times sine x, that is equivalent to sine squared x divided by cosine x. And since we have common denominator, we can subtract the numerator, 1 minus sine squared x, and just copy the denominator. And we know that by Pythagorean identity, 1 minus sine squared x is equal to cosine squared x divided by cosine x. And what is cosine squared divided by cosine? Just like x squared divided by x, that is x. So for cosine squared over cosine, that is cosine. Okay, so we already proved that the left side is identical to the right side. In this case, so this is based on sine squared x plus cos squared x equals 1. So we solve for cosine squared. That is transpose sine squared, so minus sine squared x. So as you can see, the value of 1 minus sine squared x is equal to cosine squared x. Okay? Hopefully clear yun. So we go now to the next example. How about yung second? We have number 2, sine theta divided by 1 plus cosine theta plus 1 plus cosine theta divided by sine theta equals 2 cosecant theta. So in here, we have to manipulate the left-hand side still. So since we have different denominator, we can just combine by getting the LCD. And we know that the LCD is simply the product of the two denominators. that is sine theta times 1 plus cosine theta. And we just cross multiply. So sine times sine, that is sine squared theta. Then 1 plus cosine times 1 plus cosine, that is 1 plus cosine theta squared. Okay? And that is equivalent to sine squared theta plus, what is the expanded form of 1 plus cosine theta squared? So first, we square the 1. 1 times 1, that is 1, plus twice the product of the 2. 1 times cosine, that's cosine, times 2, 2 cosine. Plus cosine theta squared, cosine times cosine. So cosine squared theta divided by sine theta times 1 plus cos theta. And we know that sine squared plus cosine squared is 1. This one, sine squared plus cosine squared is 1. So 1 plus 1 plus 2 cos theta divided by sine theta times 1 plus cos theta. And we now have 1 plus 1, that is 2, plus 2 cos theta all over sine theta times 1 plus cos theta. By factoring, we have common factor of 2, factor out 2. That's 2 times 1 plus cosine theta divided by sine theta times 1 plus cos theta. So as you can see, we can now cancel 1 plus cos theta, and now we have 2 over sine theta. And we know that this is the same as 2 times 1 over sine theta. And by reciprocal identity, 1 over sine is equal to cosecant theta. Therefore, we now have 2 over cosecant theta. My question on that example? Okay. We now have the next one. That is square root of 1 plus sine A over 1 minus sine A equals secant A plus tangent A. So what you're going to manipulate here is the left side, because when you think of manipulating the right side, it is not easy for us to make it to come up with a radical expression by manipulating the right. So mahirap magkaroon ng expression na may square root kung i-manipulate yung nasa right. So we do the left. So left hand side. So we have 1 plus sine A divided by sine A divided by 1 minus sine A. What will you do here is to think of way on how are you going to remove the square root. And we know that to remove the square root, we have a square of an expression so that we can cancel. And we have 1 plus sine A. We can just simply multiply this numerator by 1 plus sine A so that becomes 1 plus sine A squared. Maka-cancel na yung square root. But every time that you multiply a number sa numerator, you have to do it also sa denominator. So kaya 1 plus sine A times 1 plus sine A. So you just simply multiply both numerator and denominator by the same expression so that this value is 1, right? Kasi any number divided by itself is 1. And we know multiplying a number by 1 does not give any effect on the original value. So it becomes square root of what is 1 plus sine A times 1 plus sine A? That is simply 1 plus quantity 1 plus sine A is squared. And what is 1 minus sine A times 1 plus sine A? That is 1 times 1, 1. Negative sign times positive sign. negative sine squared A. And now we have this one, 1 plus sine A squared. And what is the equivalent of 1 minus sine squared A? That is cosine squared A by Pythagorean identity. So as you can see, we can now remove the square root because the square root of 1 plus sine A squared, just cancel the squared, becomes 1 plus sine A. And the square root of cosine squared A, just remove the square root, that is cosine A. And then we have to decompose the fraction, this one, by what? Expressing this as a sum of two fractions, similar fractions. So that is 1 over cos A plus sine A over cos A. And as you can see, 1 over cos A is secant A by reciprocal identity. And sine A over cos A by quotient identity is tangent A. So as you can see, we already proved that the equation is an identity. Any question on that example? Okay. Silence means everything is clear. So let's have the number 5. No need for number 4 because I know that we already understood how to do that. How about number 5? That is 1 minus sine x divided by cos x equals cosine x divided by 1 plus sine x. Just like what I said last time, you manipulate the more complicated side. But it seems that both sides are equally complicated or equally simple. So we consider the right hand side to, to make a little different compared to the previous examples. So you have cosine x over 1 plus sine x. What we are going to do here is to multiply by the conjugate. So what is the conjugate? If we have the expression a plus b, excuse me, the conjugate is a minus b. Just simply change the operation from its opposite. So we know that we have the 1 plus sine x here. So you multiply both numerator and denominator by the conjugate, which is 1 minus sine x. Then multiply, just simply in a factored form, that's cosine x times 1 minus sine x divided by 1 plus sine x times 1 minus sine x, that is 1 minus sine squared x. And we know that 1 minus sine squared x is simply cosine squared x, right? And then we simply divide. We have now 1 minus sine x divided by cosine x divided by cosine squared. Since the larger exponent is in the denominator, we put the cosine in the denominator. And as you can see, we already proved that this is an identity. Okay? Sige. We move to the exercises, which you already answered. Not this one. This one. You answered last time. So there's no solution on this part because of this one. So we go to the number 2. So we have 2 secant squared b is equal to 1 over 1 plus sine b plus 1 over 1 minus sine b. So very obvious that we need to manipulate the right hand side. So getting the LCD, that is simply the product of the two, 1 plus sine b times 1 minus sine b. And just cross multiply 1 times 1 minus sine b, that is 1 minus sine b, plus 1 times 1 plus sine b, that's 1 plus sine b. And as you can see, sine b will be cancelled because negative sine b plus sine b is 0. And now 1 plus 1 is 2 over 1 plus sine b times 1 minus sine b. is simply 1 minus sine squared b. And by Pythagorean, 1 minus sine squared b is cosine squared b. And by reciprocal identity, this is 2 secant squared b, because the reciprocal cosine squared b is secant squared b. Okay? How about the third one? So let's say we have tangent alpha plus sine alpha divided by cosecant alpha plus cotangent alpha is equal to tan alpha sine alpha. Okay, so we simply manipulate the left hand side. So we go now for the left hand side. So that's tan alpha plus sine alpha divided by cosecant alpha plus cotangent alpha. Okay, we just use the quotient identity for tangent. The tangent alpha is simply sine alpha over cosine alpha plus sine alpha. For cosecant alpha, we use the reciprocal, that's 1 over sine alpha. And for cotangent, that is cosine alpha over sine alpha. And we simply combine. So this one, the denominator is cosine alpha. This, we have a 1 here. Then we simply multiply, cross, sine times 1, that's sine alpha. Plus sine alpha times cos alpha. So sine alpha, cos alpha. Then for this one, we simply copy 1 plus cosine alpha divided by sine alpha, because we have a common denominator. And then that becomes sine alpha plus sine alpha cos alpha divided by cos alpha times, get the reciprocal of this. Okay, sine alpha divided by 1 plus cos alpha. Okay, so sometimes at the middle or end of the solution, you will realize that you don't need to distribute or to multiply, but just express in factored form so that you can cancel something. Same is true with this one. This sine alpha plus sine alpha cos alpha, you need to factor out sine alpha so that you can cancel 1 plus cosine alpha, right? So factor out sine alpha times that sine divided sine is 1. Sine cos divided sine, that's cos alpha. Divided by cos alpha times sine alpha over 1 plus cos alpha. So makakancel si 1 plus cos alpha. And again, what's the given here? Tangent sine. Okay. And we know that sine over cosine, this one, sine over cosine is tangent alpha times sine alpha. So as you can see, we already proved that this is an identity. Okay. Sige. So that's the process of proving. So I think we can now go to the next lesson. Do not worry for those who cannot attend. So the recording will be provided later. Okay? So these are other trigonometric identities. As you can see in our lesson last time or earlier, the there's only one angle involved. Let's say angle theta, angle A, angle alpha. But in this lesson, at least two angles are involved, or maybe one or two angles are involved. How are we going to do that? Okay. So we have first set of identities or formulas, which are called the addition and subtraction formulas. So as you can see here, we have cosine A plus B is just simply cosine A times cosine B minus sine A times sine B. And for minus, that's cosine A minus B, the same, but you only change the operation. That is cos A cos B plus sine A sine B. And for sine A plus B, that is equal to sine A cosine B plus cosine A sine B. And for sine A minus B, that is equal to sine A cos B minus cos A sine B. And for tangent A plus B, that is tangent A plus tangent B over 1 minus tangent A times tangent B. And we now have for tangent A minus B, that is tangent A minus tangent B divided by 1 plus tangent A tangent B. So, this is already given, but because proving this to 4 is a little bit difficult, but we can prove tangent A plus B and tangent A minus B out of the given 4 above. So, let us have the fifth one. We prove that tangent A plus B is equal to tangent A plus tangent B divided by 1 minus tangent A times tangent B. This one. What we are going to do here is to simply use the quotient identity. And we know that tangent A plus B by quotient identity, that is equal to sine A plus B divided by cosine A plus B. And what is the value of sine A plus B? We simply use the third one, sine A plus B. That is equal to sine A cos B plus cos A sine B divided by, what's the value of cos A plus B? The first one, this one, so that is cos A cos B minus sine A sine B. Okay, what we are going to do here is to think or to strategize how you come up with this one. Look at this one, this value 1. What will you do to this one so that it becomes 1? Simply, you can divide this by this, right? Because dividing an expression with itself will give you 1. So, but you are going to divide all the terms by cos A cos B. Okay? So, what we are going to do here is divide all the terms by cos A cos B. So, we now have sine A cos B divided by cos A cos B plus cos A sine B divided by cos A cos B. Then we have cosine A cosine B divided by cosine A cosine B minus sine A sine B divided by cos A cos B. Then observe, in the first term, this one, as you can see, we can now cancel cosine B. And in this one, we can now cancel cosine A. And this, okay, so what is sine A over cosine A? Sine over cosine by quotient identity, that is tangent A. Plus, what is sine B over cosine B? That is tangent B. What is cos A over cos A? Cos B over cos B? That is 1. Minus, what is sine A over cosine A? Tangent A. What is sine B over cosine B? Tangent B. So as you can see, we already proved that tangent A plus B is equal to the right side. Are there any question on that example or on that proof? No more questions. So we proceed to the examples. As you can see, we can use we can use this addition and sum form or and subtraction formulas to find the exact value of an angle which is not a special angle. Let's say 30, 16, 45, hindi siya ganon. Let's say we have this one. Let's say find the exact value of sine 75. Okay, sine 75. So find the exact value of sine 75. Using the formula, what you're going to do here is to simply express sine 75 as a sum of two special angles. And that is equal to sine 45 plus 30. Because 45 plus 30 is 75. Then following this formula, formula number 3, this one, sine A plus B, we can now find the exact value. Let's assume that your A is 45, your B is 30. But if you want A is 30, B is 45, it will give the same result. So following the formula, sine 45 plus 30, that is sine 45, based on the formula, cos 30 plus cos 45 sine 30. And what's the value of sine 45? That is simply square root of 2 over 2. What is the value of cosine 30? That is square root of 3 over 2. I hope everyone is familiar with this. What's the value of cosine 45? That is square root of 2 over 2. And what is sine 30? That is 1 half. Then multiply square root of 2 times square root of 3, that's square root of 6. 2 times 2 is 4. Square root of 2 times 1, that is square root of 2. 2 times 2 is 4. Then combine. That is square root of 6 plus square root of 2 over 4. Or if you want, you can factor out the fraction 1/4 times square root of 6 plus square root of 2. So this is the exact value of sine 75. Let us verify. Okay, what is sine 75? So as you can see, the result is square root of 6 plus square root of 2 all over 4. So we arrive at the same answer. This one. Square root of 6 plus square root of 2 over 4. Okay? Do you have any question on that part? Okay, hearing none, we proceed to the next example. How about tangent pi over 12? What will you do to find the exact value of tangent pi over 12? Others say that we just have to convert this to degrees so that we can solve it easily. But we know that tangent pi over 12 is simply tangent 4 pi minus 3 pi over 12. Because 4 pi minus 3 pi is 12. And that is tangent. If we separate this, 4 over 12, that is 1/3. So 5 over 3. And 3 over 12, that's 1/4. That's pi over 4. And as you can see, we have now tangent pi 3, pi thirds, or pi over thirds minus pi over fourths. And then using the formula, that becomes tangent pi over 3 minus tangent pi over 4. This one, formula number 5. 6 rather. This one. Use this one. Okay. All over 1 plus tangent pi over 3 tangent pi over 4. Okay? But since available naman ang calculator, this is just an illustration on how we use this. You can simply solve na lang. So what is tangent pi over 3? That is equal to square root of 3 minus tangent pi over 4, that is 1 over 1 plus tangent pi over 3 is square root of 3. Tangent pi over 4 is 1. So the result is square root of 3 minus 1 square root of 3 plus 1. But your calculator will not give this answer because this is not simplified yet. Because to simplify, we have to remove the square root in the denominator. What you're going to do here is to multiply by the conjugate. That's square root of 3 minus. Because square root of 3 plus 1 yung denominator and the conjugate is minus 1. Okay, then multiply square root of 3 minus 1 times square root of 3 minus 1. So square root FOIL method. So square root of 3 times square root of 3, that's positive 3. Negative 1 times square root of 3, negative square root of 3. Negative 1 times square root of 3 is another negative square root of 3. Negative 1 times negative 1, that's positive 1. Divided by square root of 3 times square root of 3, that is 3. 1 times negative 1, negative 1. That is 3 plus 1, 4. Negative square root of 3 minus square root of 3 is negative 2 square root of 3. Then 3 minus 1 is 2. So as you can see, everything is divisible by 2. So we divide. 4 divided by 2, that is 2 minus 2 square root of 3 divided by 2. We just cancel 2. And we now have square root of 3. And this is the answer. 2 minus square root of 3. We check. What is tangent? Pi over 12. So as you can see, we arrive at the same result. 2 minus square root of 3. Do you have any question on that thing? Okay. Nothing. So we go back. Okay. How about this one? How are we going to answer this problem? Rewrite each expression, this one, rewrite each expression as a single function of an angle. The given here is sine 75 cos sine 28 minus cosine 75 and then sine 28. You just simply observe this one is similar to number 4, right? Sine A minus B, this one. Because sine A cos B minus cos A sine B. This means that your A is 75 and your B here is 28. Okay, on that example. Okay, and that becomes equivalent to sine A minus B because it follows this formula, formula number 4. And that is sine 75 minus 28. And what is 75 minus 28? 47. So this is the simplified form or the value as a single function of an angle, sine 47 degrees. Is it clear, everyone? Kindly give a reaction if it's clear for you. All right. Thank you for the response. How about the second one? We now have cosine 31 cosine 48 minus sine 31 then sine 48. You just simply observe that it is the same as number 1, right? Cos A plus B is cos A cos B minus sine A sine B. And therefore, that is equivalent to cosine A plus B. And your A is 31. And your B is 48. And that is equal to cosine 31 plus 48, 3 plus 4 is 7, 1 plus 8 is 9. And that is equivalent to cosine 79. Okay? And the third one is tangent 37 plus tangent 68 over 1 minus tangent 37, then tangent 68. And this is the same as number 5. This one, tan A plus B. So tan A plus tan B divided by 1 minus tan A tan B. And that is equal to tangent, your A is 37 plus B, 68. And that is equal to tangent 6, 8 plus 7 is 15. Carry 1, 3 plus 6 is 9, 10. Tangent 105 degrees. And that is the answer. Question up to this point? Okay. So we go now to the a little bit difficult example. This one. Okay. If this one. So if cosine A is 3, negative 3 fifth and sine B is negative 12 13, where A is in quadrant 3 and B is in quadrant 4, find the value of the following. Okay? We consider first cosine A is negative 3 fifth. And meaning, and also A is in quadrant 3. Also, sine B is equal to negative 12 13. B is in quadrant 4. In this problem, you just simply get the partner of cosine A, that is sine A, sine B, that is cosine B. So we get first cosine A, so for sine A. How are we going to get the sine A? We can use the identities, but we can also use the SOHCAHTOA. For the sake of easy discussion, we just use the SOHCAHTOA. Okay? So if we have angle A and we have cosine, and we know that cosine is ka, adjacent over hypotenuse. So ang adjacent mo is 3 at ang hypotenuse mo ay 5. So we can now solve for this one. The opposite side, let's say x. What will you do here is use the Pythagorean theorem. That's x squared is equal to 5 squared minus 3 squared. We use subtraction because the missing is the leg, not the hypotenuse. So x equals 5 squared, 25, 3 squared, 9, and 25 minus 9 is 16. It gives us 4. So this is equal to 4. And by simply getting the value of sine using the SOHCAHTOA, sine A is simply opposite over hypotenuse. The opposite side is 4. The opposite of angle A is 4. And that the hypotenuse is 5. But take note that A is in quadrant 3, meaning both cosine and sine are negative. Kung negative si cosine, negative din si sine. Therefore, sine A is negative 4 pip. We solve also for tan A for future use. So tan A is just opposite over adjacent, right? And the opposite is 4 and the adjacent is 3, 4/3. And we know that tangent is sine over cosine, and since both sine and cosine are negative, therefore tangent is positive. So we now have a complete list for cosine A, for angle A. We solve now for B. Sine B is negative 12 13. Okay? So let's say this is our B, and sine is opposite over hypotenuse. And this is the opposite side, 12, and this is the hypotenuse, 13. And we solve for this x. That is simply 13 squared minus 12 squared by Pythagorean theorem. 13 squared is 169, 12 squared is 144. Ay, 169 minus 144 is 25, and the square root of 25 is 5. So therefore, the value of this is 5. So we can now have cosine B. Cosine B is just adjacent over hypotenuse. So 5 over 13. And how about, and that is positive because in quadrant 4, x, which is represented by cosine, is positive. Okay? And tangent B is simply opposite 12 over 5. And negative siya because the value of sine is negative while the value of cosine is positive. Dividing them gives a negative value for tangent. So we now have a complete list. We can now solve for the given problem. And that is the value of cosine A plus B. So what is the value of cosine A plus B? Simply use the formula. Cosine A plus B is simply cosine A cosine B minus sine A sine B. And what is cosine A? We go back here. Cosine A is negative 3/5, the given. What is cosine B? Cosine B is 5 over 13. What is sine A? That is negative 4/5, this one. And sine B is the given, which is negative 12/13. So what is negative 3 times 5? That's negative 15. 5 times 13, 65. Negative 4 times negative 12, that's positive 48. 5 times 13, that is 65. And what is negative 15 minus 48? Negative, negative, that's positive. So, okay. So that is 8 plus 5, 13. Carry 1, 63. So that's negative 63 over 65. So the answer for cosine A plus B is negative 63 divided by 65. My question? Wala. How about sine A plus B? So again, we use the formula. The value of sine A plus B is simply sine A cos B plus cos A sine B. Then substitute. What is our sine A? Yan. Sine A is negative 4/5. And what is our cos B? 5/13. And what is our cos A? The given value, negative 3/5. And what is our sine B? That is negative 12/13. Okay. Then we simply multiply negative 4 times 5, that's negative 20. 5 times 13, that is 65. Plus negative 3 times negative 12, that's positive 36. 5 times 13 is 65. Negative 20 plus 36, that is 16 over 65. So the answer is 16 over 65. Do you have any question on that? Nothing. So we proceed to the next example. We have now, let's say, cosecant A minus B. First, we know that cosecant A minus B is simply 1 over sine A minus B by reciprocal identity. So what we are going to do here is to simply get first the value of sine A minus B, then just get the reciprocal of the answer. And what is sine A minus B? That is sine A cos B minus cos A sine B. And actually, this is the same values here. Sine A is negative 4/5. Cos B is 5/13. Cos A is negative 3/5. Sine B is negative 12/13. And that's negative 20 divided by 65 minus 36 over 65. Instead of addition, we just subtract negative 20 minus 36 is negative 56 over 65. And that is the answer. How about the tangent A plus B? So tangent A plus B. We can use the formula for tangent, but also we can use the quotient identity. But because we know already the value of sine A plus B and cos A plus B. Okay? To make the solution simple. So what is sine A plus B? By the way, this is not yet the answer pala for number 3 because this is only sine A minus B, and therefore cosecant A minus B is simply 65 over 56, negative. Because we need to get the reciprocal. Okay, so yan. Sine A plus B divided by cos A plus B. And what is sine A plus B? Number 2. Yan. Sine A plus B is 1665. And what is cosine A plus B? This one. Cosine A plus B, negative 63 over 65. Then you divide, and you notice that we just simply cancel the 65, and the answer is negative 16 over 63. Okay? But if you want, you can just use the formula for tangent. What's our formula for tangent? Tangent A plus B is simply tan A plus tan B over 1 minus tangent A tangent B. Because we have the value of tangent A and B. So what is tangent A? We go back here. Ayan. Makikita nyo, that's tangent A is 4/3 and tangent B is negative 12 pip. Tan A is 4/3. Tan B is negative 12 pip. 1 minus 4/3 negative 12 over 5. When you solve this, the result is negative 16 over 63. So we just get our calculator. And so yan. 4 over 3 plus negative 12 over 5 divided by 1 minus 4/3 times negative 12 over 5. And as you can see, the result is the same. Yeah, negative 16 over 63. Okay, ayan. Do you have any question on that part? Hearing none? Okay, we will just finish up to this part. Double angle identities, then we will go to half angle identities next meeting on Tuesday. So we go now to the double angle identities. Okay. So we go to double angle identities. Yan. Okay. So number 1, the first identity is cosine 2 theta. How do we arrive, or how do this cosine 2 theta becomes cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1? You just simply express cosine 2 theta as a sum of two angles. And we know that the two angles that will give you 2 theta is simply theta plus theta, right? Because cosine theta plus theta is the same as cosine 2 theta. And we use the formula for addition, the previous one, that cosine theta plus theta is simply cos theta sine theta, I rather cosine theta, plus o minus sine theta sine theta. This one, oh. Yan. Cos A plus B, cos A, cos B, sin A, sin B. But A and B are equal. In that case, A and B is equal to theta. And what is cosine theta times cosine theta? Cosine squared theta. And what is sine theta times sine theta? That is sine squared theta. And this is the first value of cosine 2 theta. This one. And we can arrive at other two values because we know that the value of cosine squared theta is 1 minus sine squared theta, right? Using the Pythagorean identity, we can simply replace cosine squared by 1 minus sine squared, yung Pythagorean identity, minus sine squared theta. Then negative sine squared minus sine squared, and that is negative 2 sine squared theta. Yan, that's why we have this one. How about 2 cosine squared minus 1? We know, we go back to the cosine squared theta, this one, minus, we know that sine squared theta is equal to 1 minus cosine squared theta. And that is cosine squared theta, negative 1 times 1, that's negative 1, negative times negative, that's positive, cosine squared theta. And cosine squared plus cosine squared is 2 cosine squared theta plus 1. So as you can see, we arrive with this one. Okay, how about the second double angle identity? The sine 2 theta. And that is the same as sine theta plus theta. And that is equal to sine theta using the addition formula cos theta plus cos theta sine theta. And as you can see, sine theta cos theta is the same as cos theta sine theta. We can just combine, giving us 2 sine theta cos theta. And that is the second identity. This one. Sine 2 theta equals 2 sine theta cos theta. Okay? Hopefully, nasusundan pa natin. How about tangent 2 theta? That is equal to tangent theta plus theta. And that is equal to tan theta. Formula again, plus tan theta. 1 minus tan theta times tangent theta. And what is tangent theta plus tangent theta? Similar yan, so we can combine. That's 2 tangent theta. What is tangent theta times tangent theta? That is tangent squared theta. As you can see, we arrive with the third one. This one. Okay, hopefully kaya pa natin. So, yan, we use these things on answering these problems. Let me finish lang this is slide number 7 so that we can end. Okay, we delete this one. Sana nagkakaintindihan po tayo kahit po konti-konti. I'm trying to make it a little serious because it is recorded. Ano? Okay, sige. Right. So we solve. Rewrite each expression as a single function of an angle. So we have number 1, 2 sine 75 cosine 75. And that is very obvious. That is this. It follows this formula. Sine 2 theta equals 2 sine theta cos theta. Right? Yan. 2 sine theta is 75. So we just simply substitute 75 for theta in this left side. So sine 2 times theta, which is 75 degrees. And the answer is sine 150 degrees. That's the answer. Clear tayo dyan. How about the second one? 1 minus 2 sine squared 37 degrees. O, edi meaning, ito yung sinusunod niya. Yan. So, ano ba ang value ng 1 minus 2 sine squared theta? That is cosine 2 theta. And ito, gagawin mo lang siyang cosine 2. And what is your theta? 37 degrees. And the result is cosine 37 times 2, 74. And yan yung answer. How about number 3? We now have 2 tangent 31 divided by 1 minus tangent squared 31 degrees. Very obvious that this is equal to tangent 2 theta, and your theta is 31. And what is 31 times 2? That's 62. So the answer is tangent 62. Clear po? Nakuha natin? Okay. So, meron pa ba tayong 5 dito? Let me check. Okay. We have 7. Okay, 7. Sige. We go now to the last problem. Number 2. Ay. This one. Yan. If cosine theta is 40 over 41 and theta is between 3 pi over 2 and 2 pi, find the value of the following. So it's a given. Cosine theta is 40 divided by 41 and theta is between 3 pi over 2, 2 pi. Eh, alam naman natin, kapag between 3 pi over 2 and 2 pi, yan ay nasa quadrant 4, right? Between 3 pi over 2 and 2 pi, and kapag quadrant 4, si cosine ang positive, negative si sine. So we solve for the value of sine theta first. So if cosine theta is 40 over 41, sige, instead of the SOHCAHTOA, we can use down naman the identity para may variation. So that's sine squared theta plus cos squared theta equals 1. And we solve for sine theta. Sine squared theta equals 1 minus cosine squared theta. And getting the square root, and since quadrant 4 is negative yung sign, we just put the negative na lang dito. 1 minus cosine squared theta. Substitute lang natin. What is cosine theta? 40 over 41. Quantity squared. Then you simply use your calculator na lang. Diretso na natin yan. Square root of 1 minus 40 divided by 41. 9 over 41. That the answer is negative 9 over 41. This is our sine theta. And using this, we can now find the value of the following. Okay. The first given is sine 2 theta. So that's the value of sine 2 theta. We know that this is equal to 2 sine theta cosine theta. Simply substitute 2. What is the value of sine theta? That's negative 941. What is the value of cos theta? 40 over 41. Then multiply. Simply use the calculator. So 2 times 9 over 41 negative times 4041. Ayan. So the answer is negative 720, 1681. Negative 7, 20, 16, 81. Okay? How about the next problem? Secant 2 theta. So we have secant 2 theta. And we know that secant 2 theta is the same as 1 over cos 2 theta by reciprocal identity. So we are going to find first the value of cos 2 theta. Kahit alin sa tatlo yung pwedeng maging formula natin for the cos 2 theta. This one, another one, and another one. We can choose anything. I choose the green. 2 cosine squared theta minus 1. So we have 2 cos squared theta minus 1. That is 2. What is cosine theta? 40, 41. Quantity squared minus 1. And it gives us 2, 40, 40, 40 over 41 squared minus 1. The result is 5019, 1681. So 5019, 1681. Therefore, the value of secant 2 theta is just the reciprocal, 1681 divided by 1519. Okay? And the last one is cotangent 2 theta. Same process. We simply get first the value of tangent 2 theta. That is using the formula 2 tangent squared. Okay. Sige. But as you can see, so that we can know when we don't need to find the value of tangent theta. Since you can see here that we have cos 2 theta and sin 2 theta, we can simply get the value of sorry, directly the value of cotangent 2 theta. That cot 2 theta by quotient identity is simply cos 2 theta divided by sin 2 theta. Diba yun yung value ng cotangent? And what is cos 2 theta? Yan o, 5019, 1681. Divided by, what is sin 2 theta? This one. Negative 720, 1681. So what's the answer? We get the reciprocal of this. So para magiging 1519, 1681 times the reciprocal, negative 1681 divided by 720. Cancel, cancel, and the answer is negative 1519, 720. And that is the value of cotangent 20. Okay?